Have you ever wondered, when you look up at the stars in a clear night sky, whether life on another planet is looking back?
The Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets.
The clearest, most jaw-dropping image of Proxima B has just been revealed by the James Webb telescope. And what's hidden in that snapshot might shake everything we know about space. And there's more. Signals from Proxima B have scientists on edge, wondering if we're seeing the first hint of something extraordinary. What's hiding in that distant world? Let us dive deeper and get ready for a surprise that might change our place in the universe forever. Signals detected from Proxima B. The James Webb Space Telescope recently got some really clear images of Proxima B. What's really got scientists scratching their heads is this faint signal they picked up from Proxima B. It's not confirmed as anything like aliens saying hi, but it's enough to make people wonder if we're looking at some kind of biosignature or even a sign of technology. There's no proof either way, but it's enough to keep the research teams glued to their monitors, digging for more clues. But there's one detail that has everyone holding their breath, something that might change everything we thought we knew about our cosmic neighbors. One side of the planet might always be facing the star, meaning it's stuck in a permanent day, while the other side is forever night. So if you lived there, you could pick between boiling in eternal sunlight or freezing in never-ending darkness. Sounds like a pretty tough place to live, no in between. There might be some spots near the Twilight Zone where the temperature isn't so extreme, but even then, you'd probably want to bring a really good jacket. Despite the setbacks, there are some clever workarounds being explored. Scientists are looking at ways to analyze the planet from afar. By studying the light from Proxima Centauri that bounces off the planet, they can tell things like whether there's water or what the atmosphere might be made of. It's not the same as visiting, but it's still giving us some crucial insights. And who knows, maybe one day they'll spot something like a traffic light or an alien McDonald's, and we'll all lose our minds. Could it be a second Earth? Maybe, but it could also be a dead, radiation-soaked wasteland. At the very least, it's a reminder of just how vast and mysterious our universe is. We've only scratched the surface, and there's so much more out there waiting to be found. Scientists have spotted thousands of other exoplanets, some even bigger than Jupiter, others more Earth-sized. Some are boiling hot in orbit super close to their stars, while others are frozen solid. It's basically a grab bag of planets out there, each with its own weird story. And every time we get a new telescope or a better way to look at these distant worlds, we find more surprises. It's like every time we peek behind the cosmic curtain, there's something new waiting to blow our minds. The idea of finding other worlds out there isn't just about discovering alien life. It's also about understanding our place in the universe. It makes us wonder if we're unique or if life is just a common thing scattered across the stars. This planet is just one piece of a gigantic puzzle, and every new discovery gets us a little closer to figuring out what's really out there. Take a moment to consider how far we've come. Just a few decades ago, the idea of finding planets around other stars seemed almost impossible. But now, thanks to incredible advancements in technology, we've cataloged thousands of these alien worlds. We're getting a better understanding of how they form, what they're made of, and whether they might have conditions suitable for life. It's incredible to think that even with our limited tools, we've made so much progress in understanding the cosmos. There's also something called a super-Earth, which is just a fancy term for a rocky planet that's a bit bigger than our Earth. The planet falls into this category. Super-Earths are kind of a mystery because we don't have anything like them in our solar system. They could have thick atmospheres, or they could be barren wastelands. Without getting a closer look, it's hard to know for sure. But they're interesting because, in theory, they could have the right conditions for life. Scientists have also found planets called mini-Neptunes, which are like smaller versions of Neptune. They've got thick atmospheres filled with gases, and they're usually pretty far from their stars. These planets might not be great for life as we know it, but they're still fascinating. Understanding these different types of planets helps us figure out how solar systems form and evolve, including our own. One of the challenges in studying exoplanets is that they're incredibly far away. Even the closest ones, like this planet, are light years away, which makes them hard to study in detail. Scientists have to get creative, using indirect methods to learn about them. One common method is called the transit method. This is when scientists watch a star and see if its light dims slightly. If it does, that could mean a planet is passing in front of it. By measuring how much the light dims and how long it takes, scientists can learn a lot about the planet, like its size, its orbit, and even clues about its atmosphere. Another method is called radial velocity. This is when scientists look for a wobble in a star's movement. If a star wobbles a little bit, it could mean that a planet's gravity is tugging on it as it orbits. This method can tell scientists about the mass of the planet and how close it is to its star. Both of these methods have been incredibly successful in finding new worlds, and they're still being used today. We've looked at signals from Proxima B. Now let's see if it could support life. Exploring its habitability limits. One of the most exciting things about exoplanet research is the idea that we could find another Earth, a place that has the right conditions for life as we know it. The planet is one of the best candidates we've found so far, but there are others out there. The TRAPPIST-1 system, for example, has 7 rocky planets, 3 of which are in the habitable zone. That means they could have liquid water on their surfaces, just like Earth. Imagine an entire solar system full of Earth-like planets. The possibilities are endless. The hunt for exoplanets is also helping us understand our own planet better. By comparing Earth to these other worlds, scientists can learn more about how planets evolve and what makes them suitable for life. It also makes us appreciate just how special Earth is. We found all kinds of planets out there, gas giants, super-Earths, mini-Neptunes, but none of them are quite like our home. It's a reminder that, at least for now, Earth is unique and we should take care of it. The discovery of exoplanets is one of the greatest scientific achievements of our time. It's opened up a whole new frontier in astronomy and changed the way we think about our place in the universe. With each new discovery, we're getting closer to answering some of the biggest questions we've ever asked. Are we alone? Is there life out there? What else is waiting to be discovered? The planet is just the beginning. There are thousands of other stars out there, each with their own planets, and we've only just started to scratch the surface. The James Webb Space Telescope is going to keep exploring, and who knows what it will find next. Maybe we'll discover signs of life, or maybe we'll find a planet that's even more Earth-like than this one. Whatever happens, it's clear that we're living in an incredible time for space exploration. The universe is vast, and there's so much we don't know. This planet is just a small part of a much bigger picture. It's a reminder of how much there is left to explore and how little we really know about the cosmos. But that's what makes it so exciting. Every new discovery is a step forward, a chance to learn something new, and a reminder that we're part of something much bigger than ourselves. So let's keep looking up, keep exploring, and keep wondering what's out there. The journey is just getting started. To give some background, the planet was discovered in 2016, and since then, it's been all the rage in the scientific world. Why? Because it orbits Proxima Centauri, which is the closest star to our solar system, a mere 4.24 light-years away. Now, 4 light-years might not sound close, but in space terms, it's like our next-door neighbor. This planet is also in the so-called habitable zone, meaning it's just far enough from its star that temperatures might allow for liquid water. And we all know, where there's water, there could be life. But before we get too hyped, there are some issues with the planet that make the whole idea of life a bit uncertain. If the planet doesn't have a solid atmosphere, any chance of life is pretty much gone. So scientists have been asking, does this place even have an atmosphere? And if it does, what's in it? Could it somehow protect life? But the James Webb Telescope has some tricks up its sleeves. One of them involves watching the planet during what's called superior conjunction. Basically, that's when the planet moves behind the star from where we're looking. During this phase, some of the light from Proxima Centauri bounces off the planet, or off its atmosphere if it has one, and Webb's instruments can catch that light. Even this indirect light can tell us a lot about the atmosphere, as long as it's thick enough to reflect a good amount. What's interesting, or maybe frustrating, is that early studies suggest that Webb might be sensitive enough to detect stuff like carbon dioxide on the planet. Carbon dioxide would be a huge find because it could mean a stable atmosphere that might also support water. And water is a huge deal when it comes to imagining life. Though let's be real, we're still talking about a lot of maybe and what ifs here. It's all pretty mind-blowing stuff, right? But it's also a mixed bag, because let's face it, Proxima Centauri is kind of a nightmare of a star. It's constantly spewing radiation and throwing stellar flares, which makes the whole idea of life on the planet feel like a long shot. It's like trying to survive on a planet next to a ticking time bomb that's always going off. That's not to say it's impossible, but it's a lot less cozy than some of the other potentially habitable planets scientists have found. Still, Webb is doing its thing, gathering data and pushing the limits of what we know. If it finds water vapor or clouds, it would be a huge win for the idea that the planet could be habitable. If there's no sign of an atmosphere, though, it might just mean that all the radiation from Proxima Centauri has blown it away. Either way, we're learning something important, even if what we learn is that this planet isn't the paradise we'd hoped for. But even if the planet turns out to be a bust, the technology and techniques we're developing to study it are going to help us with other exoplanets. There are thousands of them out there, and we're finding more all the time. The James Webb Telescope is just getting started, and it's going to help us look at all sorts of planets in our galaxy, like those in the TRAPPIST-1 system. That's a system with 7 Earth-sized planets, and a bunch of them are in the habitable zone too. The planet is just one step in a much bigger journey. Next, we'll explore what Proxima B's atmosphere faces and if it can survive. Proxima B's atmospheric battle. The James Webb Space Telescope is changing the game. We're not just looking at stars and wondering anymore. We're actually getting into the nitty-gritty of what's happening on distant planets. With each new piece of data, we're learning more about the universe and our place in it. Whether this planet ends up being habitable or not, the mission is just beginning, and the future of space exploration is looking pretty wild. This planet might be only the beginning, but it's already been one heck of a ride. The story of the planet is about pushing the limits of what we know, not just technologically, but in terms of understanding where we fit in the universe. Human beings have always been explorers, from setting sail across oceans to sending spacecraft into the void of space. The drive to understand, to find something new, to answer that burning question of whether or not we are alone, that's the reason we keep looking at places like this one, even when the odds seem against us. The planet has captured our imagination not just because of its location or the fact that it's in the habitable zone, but because it challenges us. It challenges our technology, our understanding of atmospheres and star systems, and our very definition of what it means for a planet to be habitable. For example, one of the biggest questions is whether the planet has managed to hold onto an atmosphere at all. Proxima Centauri is a red dwarf star, and these stars are known for their high levels of stellar activity. Activity that can strip away a planet's protective layers. The flares from Proxima Centauri are intense, often bombarding the planet with ultraviolet and X-ray radiation. This kind of radiation can tear apart molecules in the atmosphere, allowing the lighter components to escape into space. If this has happened over billions of years, the planet could be a barren, rocky world. But if the planet has a magnetic field, similar to Earth's magnetic field, that might protect its atmosphere from being completely eroded, a strong enough magnetic field could deflect much of the radiation, allowing an atmosphere to persist. And that's why scientists are interested in detecting certain molecules, like carbon dioxide. If the planet has carbon dioxide, it would indicate that the planet still has an atmosphere that is dense enough to hold onto heavier molecules. Plus, carbon dioxide is a greenhouse gas, which means it could help trap heat, making conditions on the surface a bit more stable, even if the planet is tidally locked. This idea of a tidally locked planet is another intriguing aspect. If the planet always has one face turned toward its star, it creates a scenario where one half is in perpetual daylight while the other half is in constant darkness. Without an atmosphere, this would result in one side becoming extremely hot and the other side freezing. But with an atmosphere, the heat from the day side could be distributed around the planet, potentially creating a temperate zone along the terminator line, the boundary between the day and night sides. This twilight zone could theoretically be a place where temperatures are just right for liquid water to exist. We've seen similar ideas in science fiction, where a twilight zone becomes the only habitable strip on an otherwise inhospitable world. The concept is captivating, partly because it represents a balance, a middle ground that could foster life in an otherwise extreme environment. For this planet, if this kind of zone exists, it's where we might have the best chance of finding conditions that could support life, at least microbial life. The James Webb Space Telescope is currently the best tool we have to test these theories. Its infrared capabilities allow it to peer into regions of space that were previously inaccessible, and it can pick up the faint heat signatures from distant planets. When looking at the planet, scientists can use Webb to detect even the slightest temperature variations, which could hint at an atmosphere's presence or absence. A thick atmosphere would mean that heat is more evenly distributed, while no atmosphere would result in sharper temperature contrasts. The challenge is that the data we get from a place like this isn't straightforward. The star itself is so active that it can make it difficult to differentiate between the signals we're interested in and the noise generated by stellar flares. It's a little like trying to have a conversation next to a blaring speaker at a concert. You have to be really good at filtering out the background noise to hear what's important. And that's what scientists are doing, developing sophisticated methods to isolate the signal of the planet's atmosphere from the cacophony of the star's activity. One of the most exciting possibilities would be detecting biosignatures, molecules that could indicate the presence of life. For Earth, the presence of both methane and oxygen in our atmosphere is a strong sign of biological activity, because these gases are highly reactive and wouldn't coexist for long without some continuous source replenishing them. If we saw a similar combination of gases on the planet, it would be an incredible discovery, though it's still a long shot. Even if life exists there, it might be very different from what we're familiar with, and it might not produce the same kinds of atmospheric signatures. The search for habitable planets is ultimately a search for understanding. We want to know if Earth is unique or if planets like it are common. The answer has profound implications, not just for science, but for how we see ourselves as a species. If the planet, despite all its challenges, turns out to have even the barest conditions for life, it would suggest that the universe is teeming with opportunities for life to take hold. On the other hand, if the planet is barren, it might mean that habitable conditions are far rarer than we'd hoped. But even a negative result is valuable. It tells us about the limits of habitability and helps refine our models of how planets form and evolve. The journey to understand this planet is helping us learn more about our own solar system too. By comparing what we see there to what we know about Earth, Venus, and Mars, we get a clearer picture of why our planet turned out the way it did. In the vast tapestry of the universe, each exoplanet is a thread that helps us understand the bigger picture. Is Proxima B a new hope for life, or just another rock? Let us know your thoughts in the comments, and don't forget to like and subscribe for more cosmic discoveries.